an Israeli station 4x1ZK-L, and he's on 145.275. Now, if there's no frequency listed, you're just going to be able to talk directly to the ham who's sitting on Echolink. If he's put a frequency up there, he's got a link that's being transmitted, and all across 2 meters these days, there's about 7 or 8 Echolink frequencies, and there's always somebody talking in some language that I don't understand on those Echolink frequencies with somebody else in this country or around the world. So it's just we've got Echolink on one of the repeaters, right, Howard? And IRLP is another one.
KO6SY.
Right, KO6SY.
Single many.
Now this is normally, you know, you can talk around the world. It's not HF radio. There's no HF. I don't know why I put it up here, but anyway, I wanted just to mention Echolink because I can actually use Echolink to control my HF station. If I'm away from home and I connect up to KO6SY, I can bring the audio back from my radio station and I can type in a few secret codes and I can cause it to transmit and I can cause it to change frequency. So this is a picture of JT65 HF. There's a couple of different software packages, and I came here a year or so ago and presented JT65 fairly early on, and the HF version was new at that time. It's still pretty much the same. It's a busy piece of software. It's sort of intuitive. If you receive somebody and that signal up there that you can see here, this is frequency, that's time, and it's changing some frequencies up there. And if it sends CQ, if that station sends CQ, it would come up in green. And so you would double click on that station, and that would automatically put you on that frequency. This red line at the top and about there and there are the time markers. So it's on precisely for that set of time, and you can see, can't get to it. You can see it started right on time. If it didn't start and stop on time, you wouldn't decode it properly. WSJTX. This is looks a little bit like the JT65 that comes from the original developer of JT65. So here you can set all of the scripts that you're going to send out, click on it, transmit, send it out, you get a response back in this window. Everything's set up okay, you start to receive signals. Check it out. I still haven't played with it a lot because, as I said, it's very new. I think it might start to be an interesting mode for weak signal operation. So I want to get on to digital voice on HF. You're already using digital voice on what's that? VHF, UHF, star.
D-star.
Yeah, that's it. D-star stuff. Right. I know this is a big D-star radio club. I've never used D-star, but it is obviously a digital transmission of your voice. On HF though, we have a thing called FreeDV. Look it up. You can download it from freedv.org, I think it is. It's still very, very new. 14.236 on the HF band. It takes up less bandwidth than an SSB speech channel, and I can sit in the shack and have everything squelched off, muted off on HF. I don't have to hear any noises at all. When somebody comes up on that frequency, it's almost crystal clear. There's digitization errors still, but I think they will get better. The signals again have to be above a certain threshold, and if this works, we should be able to play it. So this is the software. If I start the software and I put it into analog mode, let's not do that. Let me play a file. This is not a good one to play.
Actually, if you go on through it then.
Talk to you in 2005, and we were experimenting with program television.
At the bottom, I'm decoding his information. The center of this signal is a PSK signal. The lines at the side are his voice digitized that I'm decoding.
You got a good black and white picture of me, and it emailed it to me, and I still have it. So that's been a long time ago. That was 2005.
If you can hear this, this is what it sounds like. I'll stop talking. Nice to stop. I think that comes back on. That's what it sounds like.
And
14.236.
Actually, copied.
So when you hear this noise, I know it's hard for you to hear, but that's the sound on a radio, regular radio in sideband mode. Bring this software up.
And I still have it, so.
And there's the decoded digital voice.
You're giving a very good signal.
So short bursts, I can only do short bursts, you know, just so that you can tell if you can recognize the voices. You know, this guy you might recognize. Okay, don't.
Sit down, and that seems like a reasonable amount. I don't know. For reference. Of course, I'm on the W2H. I can add compression and double expansion, and I can even add echo. So, oh man, now I'm going to look the stuff to get in trouble.
So that was Richard on digital voice, K6RBS, and it's still quite new. People are still trying to figure out where to go to use different frequencies. The only one that you regularly find people on is 14.236. There are some 40 meter, 7 meg frequencies as well. Now, rig control, I'm just looking at the time. I don't want to spend too much time on that, but you've got RS-232, but that's disappearing. You can't buy a computer today with RS-232, so now we've got to move up to USB control, and you've also got the ability with USB to bring IQ, and you'll hear this a lot more with software-defined radios. This is the ability to bring in the in-phase and quadrature phase of a signal and do the demodulation digitally in the computer. You probably don't need to know too much more than that. That's how all software-defined radios work. Now, software-defined radios are getting extremely low priced to the point where you can afford them. You know, they're cheaper than a club membership. That's a $12 software-defined radio. $12. This tunes from 45 megs to 1.7 gigahertz, and it costs $12 from China. It's a technology that has been developed for mass production. That's the beauty of it. The mass production is digital TV. So this is used, again, around the world, the world standard for digital TV. You plug this into your computer and you can watch the TV. Everywhere in the world, apart from the States. And so, and you can, of course, with this, people have hacked into it and they've pulled the IQ information out of it on those frequency bands and written software that allows you to look at this and do demodulation of all of the standards that FM, AM, SSB, everything you want. Just to sort of show a few other things on software-defined radio. This was the first soft rock. Any of you have heard? And how many of you have used a soft rock? Anybody? This is a software-defined radio. You build it yourself. Costs, I think they cost $30 or $40 when they first came out. It's a receiver only. It's been on the market now for probably 10 years or so, but it's the most basic software-defined radio. It will pick up 100 kilohertz of bandwidth, 96 kilohertz precisely, of bandwidth on the bottom end of 20 meters in this particular case. That's a full transceiver. That's a full HF transceiver, 40 meters, 30 meters, 20 meters, 1 watt out, software-defined radio. I need a computer to use it. There's no knobs on the front panel, all the knobs are on the computer. That's a software-defined radio. It comes as a kit, but you can buy it pre-built as well. And they have them for multiple bands. You can, if you're keen to do things with your hand, you can build this up as an all-band transceiver. So, as a kit, it's probably $75. It's probably the cheapest HF radio you'll get into.
Who makes it?
The design is by a guy with the name of KB9YIG. I think later on I have a website for you to go to pull information down on this. But add it to the computer. That's a full-blown computer. All right. That and that together, that's a $45 computer. Operating system is Linux. Okay, you might have to learn Linux if you only can use Windows, but Linux does have a Windows operating system as well. And there's software written to control this and to use it as a receiver. So now you need to cart around the computer, but then you've got my computer goes everywhere with me, and I don't even need this because I only need that. But if you don't have the computer, you've got it all together. What I'm trying to say here is the cost of getting into HF radio is no longer a $1,000 radio necessarily. Yes, if you want 100 watts, if you want to have all the bells and whistles, but let me tell you, all the bells and whistles are now in the software. They're no longer in fixed hard filters for CW. In software-defined radios, we don't have any filters for CW. They're fully variable in software. So,
On the 1 watt out, can you put an amp on there?
do what?
Can you bump up the power? It's only 1 watt out, you said.
Oh yeah, we've got people running these with a kilowatt out. Not in the box, no, you need to add an amplifier. But I put this into a 100-watt amplifier. I've worked some of you guys on the net. Good evening. Hang on, I've worked some of you guys on the net with this on 40 meters. I had to call a few times, but eventually somebody, I think actually I had to call on the 100-watt rig and said, listen carefully. And somebody heard me. But it came across from 70 miles from New Kuiper to Mission Viejo. Yes, sir, Steve.
That's the one I think it is. I've seen pictures online where somebody mounted that inside their amplifier chassis. And the only interface to it, it's really slick because it takes power off the transformer tap with a different rectifier and filter. The only interface to it is a USB cable.
Yeah.
Everything else is in there. There's a little extra power switch you wouldn't even know was there, and a USB port on the back of the amplifier, but the amplifier itself is a full HF station.
Yeah.
Is that Linux computer a Raspberry Pi?
Yes. Yes, sorry, I didn't say this because I didn't know if anybody knew what Raspberry Pi is. This is a Raspberry Pi. Not a strawberry pie, this is a Raspberry Pi. And this is manufactured by a non-profit organization. The list price is $35. You might get ripped off and have to buy it for $45. You can buy them from Element 14, which is a distributor in this country. They're designed and built in the UK as an educational tool for schools, and they're selling millions and millions of these now around the world. The problem has been that school kids are great at operating games. They can get on a computer and run a game, but they've all lost the abilities to program. When I was a kid, I was writing code to make some Pac-Man move around the screen. I remember loading with tape drives, so it's a lot easier. My tape drive is this little stick here, and of course the operating system is on here. I can change the operating system just by changing that. So there are different versions of Linux, and so I haven't tried to load other than the basic Raspberry recommended one. And out of here, just nothing to do with radio, HDMI video, real high quality HDMI video,